everyone. In this video, we will be solving system of inequalities by graphing. This is the fourth part. I will put the link of the first, second, and third part in the description box below. Before we jump into this first example right here, let's have a review on graphing inequalities in two variables. Please remember that if we get a greater than or equal to or less than or equal to, we're going to use a solid graph. And if we get a greater than or less than, we're going to use the broken graph. Now notice that we only use solid graph if there's a bar underneath, and we're going to use a broken graph if there's no bar underneath the inequality. Now let's jump into the first example. Okay, so in this example right here, we're gonna have a parabola. That's the first one, and then the second one is an absolute value. First step is to determine the vertex. So we're gonna determine the vertex for this parabola here. To determine the vertex, we're supposed to switch and keep. Since that is a positive 3, that would be a negative 3 and 3. So the vertex is gonna sit at negative 3 and positive 3. Going to be right here. So that's the vertex for the parabola. Now we are going to determine the rest of the dots. Again, there's a trick on how to do that. We are supposed to use an equation in order that we can determine the rest of the dots, and the equation that we're going to have would come from this equation, but instead we're going to cover the h and we're going to cover the k, and then we change the inequality into an equal sign. So then our working equation then would be, I'm going to write it down here, so that would be y is equal to negative x squared. So this is the equation that we're going to use in order that we can determine the rest of the dots. Now from the vertex, I created the table. The setup of the table would always be like this: 1 right, 2 right, 3 right. Now these numbers that we have here, 1, 2, and 3, will be plugged into the x so that we can determine where do we go, up or down. So from here, we go ahead and plug in the 1. So that's 1 squared is 1. There's a negative in front. So this becomes a negative 1, which means we are going down. And then we plug in the 2. 2 squared is 4. There's a negative in front, so that means it's a negative 4. That means we are going down. And then we have a 3, so we plug in the 3. 3 squared is 9, and there's a negative in front, so that would be a negative 9. That means we are going down. So then from here, we go ahead and plot the rest of the dots. So we from the vertex, that's what it says, we go 1 step to the right and we go down 1. So we go down, this is the next dot right here. And then from the vertex 2 to the right, 1, 2, then we go down 4. 1, 2, 3, 4. So this is where the next dot is going to sit. From the vertex, we go 3 to the right, 1, 2, 3, then we go 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the next dot. And then I'm going to reflect it across the axis of symmetry to create the parabola. Okay, so we are going to determine, are we going to use a solid line or a broken line? Since there's no bar underneath, I'm going to use a broken line for this. So we're going to use a broken line. Okay, now after this, we are going to determine, are we going to shade above the vertex or below the vertex? Now, there's a trick to do this. If y is isolated by itself on the left side, locate the vertex, and from the vertex, shade above the vertex if it's greater than or equal to, shade below the vertex if it's less than or equal to. Since this one right here is less than, so we're going to shade below the vertex. So from the vertex, we're going to shade anywhere below it. So that means we're shading this part right here. So that means these are the solutions to this inequality. Now we're ready to graph the second inequality, which is an absolute value. So please remember that we're supposed to determine the vertex first. So our vertex here would be switch and keep. So this would be negative 1 and negative 2. So the vertex would be on negative 1. So that's negative 1 is right here. And then negative 2 is down here. So this is the vertex of the absolute value. Now we are ready to determine the rest of the dots. Again, the trick is pretty much the same thing as what we did with the parabola. We're going to determine the equation in order that we can determine the rest of the dots. The trick in determining that equation is to cover the k, you cover the h, and then we are going to change the inequality to equal. So then this would be our equation. So I'm going to show the work right here. So the equation would be y is equal to the absolute value of x. So then from the vertex, okay, so I've set up the table. It's always going to be this setup here. So from the vertex, we go ahead and 1, 2, 3 to the right. And then these numbers we have here, 1, 2, 3, are the ones that we plug into the x. So if we have 1, we plug in there. Absolute value of 1 would be 1, which means that we are going up since this is positive. If we put in the 2 there, so that would be absolute value of 2 is 2. So that means we're going up. If we put in the 3 here, absolute value of 3 is 3. That means we are going up. So then we go ahead and sketch the rest of the dots. So 1 to the right, and then we go up 1. So it's going to be right here. And then the next one would be 2 to the right, 1, 2. Then we go up 2, 1, 2. So then this is the next dot. And then we go 3 to the right from the vertex every time. So that's 1, 2, 3. Then we go 3 up, 1, 2, 3. So this is the next dot. And then we are going to create it on the other side with respect to the axis of symmetry. We're supposed to be forming like a letter V here since that's an absolute value. So the rest of the dots would be here. Okay, now we're ready to determine, are we going to use a broken line or a solid line? We're going to look at this one. If there's a bar underneath, we're supposed to use a solid line. So in this case right here, we're going to use a solid line. So I'm going to draw a solid line. Okay, now we're ready to determine which side do we shade. Are we going to shade above the vertex or below the vertex? So there's a trick on how to do that. If y is isolated by itself on the left side, locate the vertex, and from the vertex, shade above the vertex if it's greater than or equal to, shade below the vertex if it's less than or equal to. Since this is greater than, we're going to shade above the vertex. So this parts right here are the ones that we shaded. This is below the vertex, this is above the vertex, and we're shading anything that's above the vertex. Okay, which means that the solution to this system of inequality is the intersection between these two, the blue and the red. So it is in this portion right here. These are where the solution to this inequality would sit. Now, others are going to say, what about if we got a point that's only on the blue? Is that a solution? That is not a solution. The ones that are on the red only, that is not a solution. The ones that are outside of these, the ones that are not colored, those are non-solutions too. So the solution to this inequality are actually sitting on this part right here. So pretty much a solution to the system of inequality is actually sitting where the two colors or the two graphs are intersecting, or where they are overlapping, or where they are on top of each other. And in this problem, it is in this portion right here. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!